It's my great honor and pleasure again to say a few words about our last speaker, about Professor Barbara Clank. So if you were here for the panel, you already know that she was one of the earlier attendees, participants in the summer school. She told me it was probably 2014, right? So Barbara did her PhD in 2011 in Groningen. So this means that she came here already as a postdoc. And she's, as I said before, a full professor of AI and computational linguistics at LMU Munich. She leads a research lab in NLP at the Center for Information and Language Processing. And she's also a professor at ITU, the University of Copenhagen, and co-lead of NLP Port. I heard that she has recently been awarded an ERC grant, which for those of you that live in Europe know that's extremely very, very important. And congratulations for that.
Thank you so much.
The floor is yours.
Thank you so much.
Thank you again for coming.
Yeah, thanks everyone for being here, and coming to this last session. Thanks, Isabel, for this very nice introduction. And it's really a pleasure to be here because, I have this direct connection to the school as a postdoc. And it's, if I just can give you a little bit of background, I started as a postdoc in Copenhagen. My colleague came, he attended the 2013 edition, and he was so amazed. He was spreading the word, you have to go there, mobilizing. And so we applied next year, and we were luckily accepted also as postdocs back then. So, I'm very grateful to have been here back then. And now I'm really happy to be here and tell you a little bit of what we are doing. I hope, this will be a little bit different from the other talks. And I want to show you a little bit of what I think is going to be important to carry on for the future. So hopefully you can take something away on this important topic of language variety. So what do I mean with that, and why does it matter? And I would like to show you a couple of directions we've been doing in the lab on tackling language variety. And I had to choose a couple of topics, so hopefully you find it interesting. All right, so let's dive in right away. We talked about digital assistants before as well, right? And if we just look at Europe, for instance, here, and the languages spoken in Europe, we actually see, there's a lot of varieties, right? But if you also look at what like these very prominent examples of NLP today cover, like Alexa, Siri, and so on, then we actually see that there's, even those big companies, there's a big gap to covering a lot of the languages and language varieties that are spoken, even if you just look at Europe as a small example. And there is this example of a very nice video, even of the 3-year-old Muriama. She's trying to speak to Siri in Galician, and you can imagine what happened, right? So the system, she doesn't understand why the system doesn't understand her, right? So essentially this shows, or is one example that is showing that we have still a long way to go to cover a lot of the languages. And I want to highlight language varieties even in order to be more inclusive for NLP. And why is this the case? Well, it's very costly, right, to develop these systems because we rely a lot on supervised learning today. But that's not the only reason, right? We also face, or that's also the kind of the challenge that we are facing is, and the beauty of our field is we deal with an object of study that's actually in itself so much changing all the time. It's very high variability also, right? So if I give you a very simple example of a single word, like nothing, right? Now think of ways you could spell it. And there is a nice paper by Dong Yang and Jack Grief that show like the varieties of nothing, spellings of nothing in Reddit comments. And now, if you think about this example, what does it show you? Show us actually. Shows us what we also touched on earlier. It's not just the word itself that we are conveying, but also this social meaning that comes with a word, right? depending on how I choose it, I might signal that I'm actually belonging to a certain minority, for instance. And what I want to show with this example is just a simple illustration of a problem of high variability that our systems today are actually facing a lot of issues with. So we are not able to essentially deal with this variability, illustrated by, like, imagine the system can only recognize the small set of varieties that are now depicted here. And so in big terms, what this means is NLP today is the more variation we see, essentially the less performing we get, less performance we get, right? And, or the higher the error rates, right? That's the same. And so what is really going to be important in the future, and I'm really happy we're working on this already, is to account for this language variability. And here, I would like to illustrate this with, we take typically input and output as our standard, right? But this is what we do in machine learning. And similarly, we can look at this problem of language variability, both in terms of the input side, but also in terms of the output side. And so if we look at where we as a field hopefully are going in the long run, is to embrace all the sorts of variability that we can see in language, illustrated by these colored dots here, right? And hopefully enable technology for a lot of language varieties, a lot of different setups, essentially. But on the other hand, there's also the output space. And hopefully we're also able to get there to be more inclusive in terms of variability on the output space, meaning that today the system, the world looks like more like this. Okay, we see like not so much of, we are not able to deal so much with variation. And in concrete, if you think back to the example of the digital system, what does it mean? Well, it means that a lot of speakers are underserved. They can't speak their own language or language variation. It doesn't recognize the input essentially. But at the same time, we are also modeling quite standard output variables typically. So it doesn't, we're not embracing even the variability in the output space. And so when I talk about we need to account for language variability, I think we really need to bring these two sides into the equation and move forward essentially. Yeah. So what I want to show you then in the rest of the talk is, okay, we do have tools, we have some methods out there that help us, and a big tool is transfer learning, right? We can move from one variation to the other or one language to the other. And I will spend quite some time on transfer learning. And then I will also touch in the last part of the talk on the second dimension, the output space, where we essentially want to go towards embracing this variation that we also see in the outputs in the labels. Okay. And yeah, this is essentially what I'm going to do today in this talk. I will first briefly go into transfer learning and give you a little bit of an overview. I'm actually wondering how many of you have used transfer learning already? Pretty sure many hands go up now, right? Yeah, so it's really, really known, but hopefully give you a new perspective on this broad topic. And then I thought about a couple of selected use cases from the lab illustrating some of these problems and how we tackle them. And then in the end, moving towards some broader conclusions. Yeah, are you ready? Yeah, all right. All right, so let's move into transfer learning. So if you think about transfer, it's meaning like transferability, right? And here what we mean is essentially we want to go from some source, say source and model A, to be able to tackle this problem that we're essentially not having the same sort of distributions in the input, right? So we need to go to another target, whatever this is, and we try to essentially not only target the target directly, but we want to use or reuse knowledge that we have gained before. That's kind of in very broad terms. And now, what can transfer learning mean, or what can this crossing the gulf mean? Well, there's a lot to be in this, in this broad umbrella. We can think about, okay, look, I'm moving from one certain type of text that I'm processing or have data or model from to another sort of data, and we transfer across this, what's called the domain gap. We might think of also cross-lingual transfer, right? When we move, say, from English to, I want to build something for, like, in this example, Danish. We might want to transfer not only to certain specific target domains or languages, but also to other label spaces, right? Other tasks. So we could also think of multitask learning as a way of transfer learning. And then I want to also put forward that there is also a lot of other things that you could try to exploit, which might exist out there. And I call them fortuitous data sources, or fortuitous or incidental learning, if you have heard that term, where you try to essentially not directly use other labels or other data, but other sorts of signals in order to process better on the target side. Yeah. Okay, so this is like a broad overview, but let's go a little bit deeper, right? So if you think of transfer learning today, and I want to give you two views of this problem in order to show you that this is actually maybe a bit broader than what you thought, perhaps. Let's see. And I take this notion, so you have a probability space over the input and some data D, and then we also have the label, right? The conditional probability that about the labels that we are trying to predict. And so if you think about transfer learning in terms of what is this gulf, right? What is this mismatch that we are trying to address? You can see it as kind of two sides. And one is, for instance, when the input changes, right? Like when we do go over to a new text domain. And then, in fact, there is a whole literature of domain adaptation. And as Xavi, I really like that he pointed it out, this is something that exists since a long time, right? Early 20, really long time ago, 2000s, people were working on this problem. But this is now gaining, again, attention much more. So domain adaptation of these methods are worthwhile reinvestigating also with the methods we are using now. And then we have another type of distribution shift, which is maybe, not only distribution over the features changes, but maybe the entire vocabulary changes. And we go to a new language, for instance, and we then see, okay, actually we are dealing with a cross-lingual learning problem here. And if you then go in the other direction and think more in terms of the output space, the labels that change, then you could think of, okay, now perhaps I need to go and see how can I apply multitask learning to bridge this gap. And but this is not the only dimension. Then we can also bring in the timing dimension. And what does this mean? When do we have data at what point? And then the whole sequential transfer and continual learning paradigms come up. Okay, so this is, you see, transfer learning is not just, essentially fine-tuning, right? Today, there is also this shift in terminology where we often refer to transfer learning only by meaning, okay, I'm fine-tuning my whatever bird model or language model on a certain labeled task, right? So I want to really bring forward that this term has nowadays often that connotation, but transfer is a much bigger problem that deals with all the sorts of variation that are also even interconnected with each other. Yeah. So perhaps, just looking at this is my personal take, is very myopic, right? We have a lot more to be looked at here. So transfer learning is much broader than this. And now we looked at the input, what is actually this data mismatch that we are dealing with. The second kind of view we could take is, hey, what is actually the types of resources that we have at our disposal for transfer? And here, again, the question is, what sort of target data can be used? So what kind of, again, assumptions can we take? And then here we can, again, try to depict it into, okay, maybe we don't have any target data. What kind of methods apply to that case, right? Like zero-shot learning. Or maybe we do have some labeled data, and then we enter the sphere of few-shot learning. And now, again, things change on, okay, what does it mean to be doing few-shot learning? Is it really, again, maybe I really want to highlight that terms, even within our community, are changing all the time, right? So few-shot learning a few years ago was really assuming you have a couple of labeled samples and you update your parameters. But now it's even meaning in context learning where you don't do any parameter updates anymore. So that's what I try to depict with these two arrows here on the upper line. And I know that you heard a lot about that in earlier talk this week. So that's great, in fact. And, you know, now this is a very rough overview and it's not necessarily incomplete, right? Because it's a huge space. And that's why I also want to point out that, you know, I'm talking here about transfer learning in this direction where we try to reuse knowledge and in order to address this lack of data. But there is a huge alternative literature, which I'm not touching upon here, which probably some of you are working on, right? So you could, instead of reusing and transferring models, you could really try to essentially generate labeled data, or you could also use methods that give you pseudo labels or involve bigger models, involve the human in learning, or try to find even other sources of information that you can use for supervision signals. Yeah, I hope this gives you some overview of what's out there. And I also want to point out that there is this awesome tutorial by DJ Yang, Arthur Park, and Colin Raffel. So they gave a tutorial at ACL where they covered on these two aspects, right? You could really go deep in any of those buckets, essentially. All right. Anyone, any questions up on this point, maybe? No? All right. Are you ready then to dive into some examples? Yes, all right. So now we want to go into these three essentially papers and give you a little bit of details, especially in the second one, on the one on multitask learning. And let's see actually the timing, right? So the roadmap for the rest of these three use cases is as follows. So we want to use, first of all, we're tackling now structural prediction problem in the first part, which is parsing. And we want to know if we can improve parsing by using some sort of fortuitous accidental data that's there that we haven't used, essentially. Can we make low resource parsing better by exploiting some information that is available as fortuitous metadata? And sorry, so the goal of the setup is as follows. We want to do a cross-lingual transfer here. Say we want to go from English to, imagine, Danish, okay? And we want to, what we typically do in cross-lingual transfer is, okay, we're actually transferring a model which is perhaps trained on newswire data from English to Danish newswire data, right? It really depends on what's the target or the language and the domain that we have at the disposal. But what we really want to have is models that can actually deal not only with news, but say we want to also be able to process Danish literature or Danish reviews or Danish music, text, lyrics, whatever, right? We would like to have a model that we can transfer, but to specific target genres, okay? And this is a problem that's not so much looked at. Typically, we only have this horizontal dimension from one language to another, but there is this other dimension, right? Like genre, you could see as a secondary dimension of variation. And so we were wondering, in this paper that we published, so with Max, my PhD student, and Rob van der Groot, we were wondering, can we actually use genre label information in order to improve cross-lingual dependency parsing? I'll give you a little bit more motivation here, because actually for this task of parsing, we are very lucky that we have awesome material at our disposal. So there is the Universal Dependencies tree bank that was briefly mentioned also by Slav Petrov in his talk. And this is a huge and nice collection of annotated tree banks. So each of these boxes here represents a tree bank of a specific language. And they're really wide in that they cover a wide variety of genres as well. And now this is a project that now covers over 200 languages and it's running since a long time. But we also know if you now say you want to build a parser for ferries, for instance, right? How do you do this? How do you start such a tree banking project? Or you could think of, hey, I want to reuse the existing knowledge, right? And that's where we kick in here. So you could train a parser on, well, let's assume there is no ferries. So what do? Maybe select Danish. select all, right? That's the question. It's kind of a practical problem as well. And so what we were wondering here, we know that we can train a parser on all of the languages together, now with multilingual embeddings, for instance, but we know also that this is also slow, and we know that this is not the best solution. And so what can we do in order, the question is, how can we make this better by selecting specific subsets of data? So do data selection for finding more targeted training material. And the key idea here is essentially to use these genre labels as a sort of fortuitous metadata. And what this means is essentially each of these has a label, and can we essentially use this as a proxy for target data selection? Okay? So the secondary question then, what emerges is, okay, we know that multilingual models to some degree capture kind of topic dimensions, but in monolingual spaces, or in monolingual embeddings. But how does this look in multilingual embeddings? Do we still see some sort of topical genre dimensions, or is it really just language that overrides the signal? So in this paper, we are trying essentially, let's assume we pass, say, Danish fiction, and we want to select a subset of data from the whole, which helps us to hopefully pass the target better and helps to bootstrap, say, a low resource tree bank. Notice now, you might have noticed that I use genre and domain maybe somehow interchangeably. And in fact, this is a term which is not very well defined. You also see linguists talking about registers, right? Like registers of language use. And therefore, in this work, we don't try to define the notion of genre. We take a very pragmatic approach that we take these 18 community-driven labels that exist and come with the Universal Dependencies project. And so the first thing that we did was, hey, how does this look like actually? How do these labels, what are they, and how much of each kind do we have essentially? Just a notice, there's very little documentation about these genre labels, and the paper by Joachim Nivre essentially even comments on this. So these are, they are provided, notice they are under quotes, right? Genre labels are provided by the tree bank providers, and they are neither mutually exclusive nor based on homogeneous criteria, but it's currently the best documentation that can be gained to document what are the tree banks about. And so let's look a little bit at what is in this distribution. So here now on this plot, you do see all these 18 labels. And what you perhaps notice, and we here try to measure how much of the data falls into a certain category. It's actually non-trivial to measure because tree banks might have any number of these labels, okay? So the lower bound is essentially only counting single genre tree banks. And what we see is there's a lot of newswire, right? There's a lot of bias towards news data, nonfiction data. And there's a long tail of, social, poetry, medical, email. So if you want to process that kind of data, probably your system will not work that well because there's very little data about it in the UD. Okay, and so knowing this, our setup is we have a certain target, we have all of this UD, so now each of these is a tree bank, each of this is a sentence, a tree in the tree bank, and we want to find out, okay, if you pass this red target, where are the red instances, because presumably they are the ones that help us build a good parser. Now, if the world would be easy, we would know the labels for each of the instances would be a trivial problem, right? We could just select and test this hypothesis directly. But the problem is that it looks more like this, right? So we don't have these labels at the instance level. So we only have essentially labels at the target tree bank level. So it looks like essentially like this, okay? So we have these labels, and we know that these are the genres contained in the tree bank, but we don't know much more. And there are also, and that's also key, there are some tree banks which are set to contain only one genre. So can we make use of this information? And what we do in this work is essentially, trying out several ways to select data. One obvious first step is to just embed all the sentences and try to find close sentences in the embedding space, right? So this is what we call the sentence baseline. And you don't, essentially all dots are in one pool and you just pool them all together via mbert and then try to find the closest ones, right? Now, we compare this to the obvious practitioner's guideline that is, okay, you know you're passing the red one, which is like G5, so you select all 3 ranks which contain G5, and that's kind of the upper bound, I mean, the practitioner's solution, right? So the question is, can we do better by kind of bootstrapping or using different ways of selecting data than the sentence-based representation? And what we did in this paper is testing different ways. So like a bootstrapping approach where we start from, okay, we know we train a classifier that tries to predict the labels by inferring them from single genre and double genre so that we can actually resolve the whole in 3 steps. And so the classifier will then tell us about what is the instance, what genre is the instance following, so on. And then we compare this also to a clustering approach where, because we are relying now on multilingual BERT as representation, right? But we also have the 3 bank label information. So what if we first cluster on the surface form, right? On the words or the characters, and then use the sentence representation by multilingual BERT. And that's what we do in the clustering approach. So we cluster first 3 banks with a very simple method like Gaussian mixture models or LDA, and then represent the mean, the centroids by embeddings and try to query them then to the closest centroids essentially. Okay. So is this okay? Is this all clear what you try to do? So we compare essentially different ways to select data out of this pool. And we want to know how does this compare to baselines like practitioners' baselines and other baselines. So we tested this on 12 target languages, very low resource languages between 200 and 2000 targets. Notice they also differ whether they are in multilingual BERT, and notice that we only take single genre targets. So we're trying to say spoken Cantonese is one of the targets. Okay. And what we then saw is essentially, okay, what we do is we try to find this proxy data, we train a parser, and since we have, in this case, evaluation data, we can compare and compute LAS. And now what do we see? So this is just the parser that we're using. What we see is essentially, okay, remember this is low resource. We don't assume any target language data. We really transfer from other languages. So we see that it's a very tough problem because we get an LAS around 36 if you do the sentence-based selection, which is kind of like random selection. So the sentence-based representation is not good enough to outperform on average the random selection. But what we saw is overall these are all the ways that metadata or genres is used. So the using all of the data by just taking the labels is actually worse. So taking more is worse than taking less. It's also 8 times more data. While in the other settings, we try to control for size to be similar to this one. Similar to this one, essentially. And what we see is that this genre-based selection does help us to improve low resource parsing. On average, maybe the results are not super impressive, but still for some languages like here, Faris, we got quite impressive improvements, or even over, say, an upper bound, which tries to train on small amounts of in-language data. Okay, so key message here is this genre selection does help us. So, but it's also, it's still a lot more to be done to really push these scores up to on average, right? But then the second question here is actually, can we, what happens to these multilingual embeddings if we look at where the clusters are? So here we see that actually multilingual BERT that we used here, out of the box, interestingly, already captures some of these genre dimensions, right? You see that there are these blue and light blue boxes, clusters already. But when we used in our bootstrapping approach, we could see that we can tease them even more apart, and that helped us to do better target selection. So there is inherently already genre information encapsulated even in this high multilingual embedding spaces. Yeah. So the takeaways from this study are that genre is a valuable signal for parsing specific low resource targets, and that we saw that genre is captured in these multilingual representations. And I think it's worthwhile to think about these other sorts of sources of information for low resource problems. Yeah. So some related follow-up work by this is essentially, you might wonder, okay, what about these categories? What is in UD? Can you even predict it at the instance level? So Max was looking at this problem, and he studied in depth what are these labels, finding some actually surprising results. Also, we have an email label, and email is essentially also capturing letters to Dante, really old letters. So you find some surprising facts in the data. And then another work that we were doing is, can we, essentially try to look more into these language model representations? There's a lot of literature on probing, right? And there's a lot of literature also showing that they capture syntactic information out of the box. But what that literature was essentially, it didn't go all the way to do like full parsing. So we tried to propose a very simple probe that can do both directed and labeled graphs in a very tiny parameter space. So it's a probe which can do parsing essentially in simple terms, and is much more efficient than the whole parser, and it correlates well with full parsing. So if you need to essentially, and that's what we did in the next study, what language model do you actually pick when doing low resource parsing, right? Which ones do you select? Have you questioned that yourself at some point? How do you choose? Huh? I didn't hear what you said. The fact? Yeah, yeah. So we were wondering essentially, okay, there is, you pick the typical ones that everyone else is using, but there's monolingual ones and other multilingual ones. So we try to look at, hey, can we actually use this probe to predict which one is the better encoder for full parsing? And we saw that this is actually helping us to find efficiently which language model to use, for instance. But much more work is needed in this direction. So just one plug here. Yeah, any questions? I'm happy to take questions now on this part. Is there any? Yeah, go ahead.
First, is there a formal definition of what's a low resource language?
That's a good point. No, there is not, because now I even took the example of Danish, and I would not really characterize Danish as a super low resource language, right? Because there is quite some work on it. It's always relative, right? So no, there is no. I think it would be even hard to really define it, but it's disadvantaged in respect to the higher resource languages, right? Mm-hmm. Yeah. Right. All right. So now for the second, I'm also happy to take questions later on any of the parts, essentially. Now, in the next use case, we were interested, actually, this was a study. So Rob was working or we were working on information extraction for spoken language understanding. Essentially, the task is you get an utterance and you want to try to find what's the intent of the utterance and what are these slots, right? It's kind of an information extraction problem and classification problem. And we were interested in, when we started this project, there was a little bit of multilingual data sets around. This was 2020, actually, when we started this. And we were interested, hey, can we actually improve upon this problem by also looking at creating a new data set that contributes to this multilingual slot and intent detection problem. And so we created a data set that we'll describe in a second, but we were also interested in, hey, if you do a cross-lingual transfer to this, okay, we have a model which predicts slot and intents, but we might have a lot of different data out there that we could use in order to try to help with this problem. And so we were interested in to what degree do non-English data or non-English auxiliary tasks help us to improve upon slot and indent detection. So you can imagine now, okay, we try to see different ways to integrate other data sources, which are not necessarily the same type of data, into the same system via multitask learning in order to see whether we can improve transfer from English data to a set of target languages for which we also created a new resource. And so just a few words on multitask learning to bring everyone here up on the same page. So that's a kind of idea where instead of building a separate model, you're trying to reuse knowledge, right? You're trying to essentially share parameters in the model, and you try to predict not only one task, but you're typically adding multiple heads in order to improve on, have a model that can deal with both at the same time. And so that's why, you know, if you're interested in a main task and not all tasks are equally important, then you often call this other task auxiliary task or supplementary tasks that help your main task, right? And so just a short note, why would we want to do so? From a scientific point, it might be interesting to, again, create some more general language models or general understanding models and try to reuse knowledge, right? But there's also this practical view that multitask learning can help us to generalize better and also help us to be more efficient in learning, okay? Now, why that actually? Well, by sharing parameters, there's a nice literature on, you know, you're trying to reduce the network's capacity, and it needs to, you know, pay more attention to the more important parts, right? That's kind of one way to see it. Or you also have like a representational bias. Nick mentions that you prefer solutions, right? Parameters that are shared between them, right? Not too specific to a certain task. And that helps you to generalize again. Or you can see it as a way to regularize, right? Not to pay too much attention to one task, but you need to essentially learn multiple tasks. And finally, it's also a way to help you with this problem that, okay, if you, for your main task, you have very little data, it's a very easy way to integrate additional information, additional data that doesn't need to be even the same sort of information. And so in this work, coming back to the paper, we tried non-English auxiliary tasks. And here what we tried is we sorted them by types of availability of this data. Okay, so what do we do if we go to, say, slot and intents in Danish? Well, we might collect raw data. Then we might have some parallel data, right? Or we might even go and say, hey, we actually also have Danish tree banks and so on. Does this structured information help us in order to improve? And so we can really see this as on the availability of data scale, to what degree, how easy it is to get this data and so on. And the model, the data that we created here, which is in fact, this was all created in the lab, and we managed to get 13 language variants. And you see how different they are just by looking also at where the slots are and so on, right? So I'm really happy that we managed to do this. Note, though, this was a project in the lab and we don't have so many resources, so this is only an evaluation set. That doesn't come with training data. So we always move from English to these targets. And what we found, so we tried all these you know, auxiliary tasks, and we compared to a neural baseline transfer method. And what we found is not always does multitask learning help us, right? So the only one that is actually quite helpful and robust across all these language variants was just doing also masked language modeling while learning the main task on English data. So auxiliary MLM was the best method in this case. And all right, so what we did then, or what I want to just briefly zoom in, is that one of these variants that we included was a German dialect. And to give you a little bit of background, where did this dialect come from? So this is here, essentially this area, South Tyrol. It's a Southern Bavarian dialect. And we collected, so the peculiarities of this dialect is it's a spoken dialect in Italy, right? There is also influence from Italian, and there's also a third language, Latin, And so you do see this also in kind of examples like here you have an example of did you do your driver's license, and we have these borrowings from Italian, for instance, in this dialect. And also like the case gender, sorry, the gender is also changing sometimes. And here to illustrate you some of the variations. So is it going to rain today? You know, just kind of, it's very, there is no standard in writing. So it might be written in different ways. And another challenge with this dialect is that while we know that the best auxiliary task was MLM, which requires raw data, and that's quite easy to get, that's not always easy to get actually, right? If you think about a very low resource language, coming back to your question, what's low resource, right? Even if you don't get data like raw data, that's really low resource, right? Like languages with not much digital footprint would be like very, very low resource. And so this is one of the examples. So we looked at social media and some forum for where people post question answer posts, and we found that this forum was kind of quite dialectal, right? While Twitter is really mixing high standards in the batch. But still, we wanted to see if this is useful. And we tried with this aux MLM procedure. And what we found is if you just do transfer with multilingual BERT, you get 49. If you use all of the data we got, like 30,000 sentences or tweets, or like sentences in this case, you can boost it. And now the question is, can you do better if you have, you know, presumably closer data, which is also question answering data, or this highly mixed data. And we saw that, again, with less data, but more closely matching the type of data we are dealing with, we could do a little bit better than using essentially similar amounts of more distant data and so on. All right. Yeah, this is the small going towards a very low resource dialect. What I wanted to present you in this paper here in this part is the proposed exit, this new multilingual evaluation data set. As I mentioned, when we did this project, there wasn't so much around. And I can, if you're interested in this problem, really point you to this survey where there is now a lot happening in this space of multilingual slot and intent detection. And they do a great job in summarizing all upcoming data sets as well. And in this work, we tried to use auxiliary tasks, found MLM to be a good one. And it's also one of the first results on this South Tyrolean dialect where we didn't have much data available. Right, right, a small detour. This was all about MTL in this section. Is that something new? No, it's not. You know, a lot of the things that we are learning today have been proposed a long time ago. Here is one of the early examples. This is Elvin, CMU car, and he had already, you know, he had the cameras and was trying to predict the direction of the steering wheel. And they already used, so Rick Carana was already involved in this project. And they tried to, you know, what I find interesting is they looked at different perspectives of the data and tried to integrate them as auxiliary tasks. So where is the center line of the road, or what's the intensity of the road surface, and trying to predict these as features in order to help build a model that does not only try to predict the steering direction, but also tries to predict these auxiliary tasks in order to help generalize better. Yeah. And so MTL today is really everywhere. So this is a quite old plot where you see how deep learning entered our fields. Soon after came a lot of work that jumped off on multitask learning. So we call it the multitask learning wave that followed. But nowadays, you know, it's really everywhere, right? So think about this one, right? Think about this guy. Is this a multitask learner, actually? Yeah, right? It's already there as well. So if you think about the tasks that BERT is predicting, it's also having essentially two objectives, right? So it's also a multitask learner, essentially, that we're dealing with. And But notice now the objectives, this is self-supervised, right? It's not called label data, but it's self-supervised labels. But essentially, BERT is already a big self-supervised multitask learner. And there is much more. You also heard about T5, right, in the other talk. This is another example of multitask learning. So it's everywhere nowadays. And what we did also, and many other people are doing, is multitask fine-tuning, right? So you take an LM and then you try to, say, build a parser that can do all subparts of parsing, pause tagging, feature prediction, morphological tagging. Like that's another example. So it's very, very successfully used. But I want to highlight that there is a lot of other interesting works coming out in this area. So you could, this is kind of the target, like the fine-tuning paradigm now with multitask learning here. But people have proposed also other ways to use data, like stills, right? So where you go and have an intermediate fine-tuning stage, right? In order to try to generalize to the target task. So use similar tasks in order to try to help you for the target task. Or, and this is now increasingly used, there's also intermediate multitask pre-fine-tuning coming out, right? So essentially, you're not only doing multitask learning sometimes here, but you also try to scale up the model by saying, hey, I want to try to go to these universal models, which I pre-train as much as I can. And then I just have to fine-tune them in my target task. Okay? And or you maybe have heard about domain adaptive pre-training, right? Where we assume we are just using plain data, which is closer to the target data, and we're trying to continue fine-tuning on masked language modeling, for instance. And so for this one, I think this is perhaps one I want to mention briefly, because this is what really comes out now a lot. And there are two seminal papers. One is the Muppet Paper, which came out last year. And what they show is, we often have this, we don't know when multitask learning helps, right? But what they showed is if you do multitask pre-fine-tuning, on here you see the number of data sets that they included. It seems like scaling up is really helping. So if you do, less than 15 data sets, you might have a negative effect of multitask pre-training, pre-fine-tuning. But if you add more, you see this positive effect in the end. And while they did it with lots of task-specific hacks and smart ways of tackling some of the issues, there was another follow-up work now that came just out, XT5, which essentially does T5 with tons of tasks. I think 107 supervised tasks in the meantime, right? And they found that helped them again to generalize. But now everything in this text-to-text scenario essentially here. Yeah, I think I skip over this in the interest of time. Yeah, there's a lot of other advantages to, you can connect multitask learning to other paradigms. There's a lot of, also efficiency that is important, but we will, let me actually just summarize this slide. It seems scaling up multitask pre-training is something that's happening now. And in general, multitask learning is often helping when there is small data, but it's not always helping, especially if you do it in the standard way. So there's a lot of more open research question on the task relationships and so on. Right, but one of the, in fact, big problems that happens is you have this catastrophic forgetting and interference problem in these kind of models, and you need to really think about how to train them, because there might be swamping, and there's a lot of ways that people have been trying to propose to circumvent some of these problems. All right, yeah, sorry, this was a bit fast now. Are you with me? Yeah, do you have any questions on this part?
Thank you very much. And I'm thinking about thought about what kind of multitask to be fair used, near task or maybe complex type task that would be helpful, because maybe intuition that we have about the task are not then useful.
Can you repeat the first part of your question again? Sorry.
Yes, it's just some intuitions about how kind of task could be very more useful, like complementary tasks or tasks that we think that are.
Yeah, that's a good question. It's really difficult. So there should be some relationship, but they should also not be completely, it's very hard to have a really, good answer to this. It's often an empirical question as well on what is helpful and what is not. And there's a lot of work also on using pairwise tasks, right? And so one kind of finding now is that if you stick to the same subgroup of tasks, like classification tasks and sequence labeling, and what's the word? Sequence element. I don't know. If you go across task types, that might be less helpful. If you then staying within task types, like classification, at least there is some work in this direction. Right. All right. Any other question? Yeah.
So I have a question about this auxiliary task and cross-lingual transfer. According to the table you have shown on the slide, there's some language where that works well, while the other task it doesn't work.
Yeah.
Do you have any insight which task those auxiliary tasks can help, or if it helps? Is there any known knowledge how we come up with a suggested language task which helpful to make it better in cross-lingual transfer?
Yeah, that's a good question. No, so this was really, you saw that we had quite mixed results in respect to the other kind of auxiliary tasks, right? And we were hoping we could find a better explanation of when passing would help, for instance, but that was generally not helping very much in this case. No, there's typically MTL is what is kind of a general broad conclusion. If it's helpful if you have little target data available and a lot of support data, so that you still keep learning both essentially. While if you have not so much support data, it might be actually helpful to do more like this intermediate still kind of training, and then just fine tuning in the end. But we need really more ways to get to formalize these intuitions, but it's also a difficult problem because this is a combinatorial problem that we are facing, right, by trying out. So yeah, no, I don't have very good answers to this question. Yeah, there was one more question, right? Yeah.
Yes, so thank you for the talk until now. I have also one question regarding this multilingual setting. So you assume you have a low resource target language and a high resource, for example, source language.
Right.
Now you have to choose some kind of embeddings.
Yeah.
And so you can choose these multilingual embeddings, or you can use, for example, translation from the high resource language to the low resource language, or the other way around. So we have some insights which you should use, or which is better, or which advantages are there?
No, this is okay. That's a great question. I think we need more work on estimating this transferability a priori to training, essentially. What we try to do with this parser re-ranking language model, which I really briefly mentioned only, right? So maybe we can find ways to probe the representations and get a better sense of what kind of language properties they encode in order to, to what degree multilingual model is still capturing that language, for instance, and so on. It remains to be seen still. It's a very good question, essentially. Yeah.
Okay, thank you.
Yeah.
Okay. So my question is also related to one of the questions that have been asked by the audience. So I think the auxiliary class and the main class, in Multitask learning, you have mentioned the research on that the mass language modeling is the best auxiliary class. Right?
Yeah.
So what I get the feeling that since the bird is already, the bird's objective is obviously the like multi-language modeling.
Yeah.
So that's why it helps a lot. So my question is, have you ever come across learning a word from scratch for a different task and compare to whatever you've shown here? Maybe, I mean, I get the feeling that if you do so, it's going to be a better comparison. So what's it? What do you think about?
So the question is whether you have tried to do a monolingual model instead of the multilingual one.
For a different objective.
No, I know that there's work, of course, comparing monolingual bird types of models to multilingual ones. And then it's also not always clear whether the multilingual or the monolingual one is better, right? Sometimes there are surprising findings even in that sphere. No, in this study in particular, we only had MBERT and XLMR. We didn't compare to monolingual ones, but there is work on exactly that question. It's like Sampo Psisalo from Turku they trained a lot of bird models on Wikipedia type of text and compared, they really had a controlled setup where it retrained monolingual ones and retrained them. Now I don't remember if they retrained the multilingual one, but they retrained a lot of monolingual ones to compare to multilingual bird in that case, I think. So they had some findings where for parsing that were sometimes the monolingual one was better as expected, but not always. So yeah, but not with other objectives than MLM. I think that's another interesting idea, right? To generally look beyond MLM objectives because they are very simple objectives. Can we integrate more structured knowledge into the pre-training? There is some work in this direction as well. Yeah, I'm not sure I answered your question completely, but yeah. All right. How much time do we still have actually, or almost? Yeah. Do you give me some 5 minutes more? Like I will try to skip a few. Yeah.
So we do it after. We'll do the closing remark after.
Okay, great. Okay, I want to just touch up on one thing that's on my heart, which I haven't touched on, and that's the output space. Okay, I tried to show you this in the beginning, but I want to point out that whenever we do annotation projects, we see annotation divergences or disagreements between human annotators. And that's everywhere. If you have done any annotation projects in class or in a project, you see them, right? And the main point I want to make is, hey, we typically try to avoid these disagreements. We want to get to one ground truth, and we model this one ground truth, right? Because that's the label that we feed in our algorithms. So, hey, why don't we see this as, take this cube, depending on how you look at it, you might see it differently, right? You might see it popping out or popping in. Why don't we do the same for our data and think about these divergences as different views, right? And they can contain important information. So now I'm calling it disagreement, but I like to think about this as human label variation, right? So what do I mean? Well, even for simple cases like post tagging, if I give you this example, I might get different answers, right? What's the tag for presenting? Is it a noun or is it a verb, right? And this is a simple example that shows that there are actually genuine disagreements in labeling, and why don't we use them, essentially? And so there is really nice work also by Elderly Public, for instance, for NLI, and they have re-annotated existing data and shown that, here you have the typical tree labels, and there's a lot of disagreement when you re-ask people to do this task. And this is something that you can observe in all sorts of tasks, like subjective tasks, more objective tasks, even language and vision tasks. You typically just take one of the answers as your gold standard. And so I want to make you rethink this essentially, and is it just random noise or not? And we did some early studies on small samples of annotated data and looked at the divergences or disagreements, and we saw that there are some systematic disagreement cases, even in post tagging. There are also some divergences, but also we can essentially see that they are not just noise. So this questions this big assumption of, hey, we are always learning with just one ground truth, right? Because we also see that from the example that Ellie gave us, that there is not just one unimodal distribution over the answers, but there seems to be many of these edge cases where we, as humans, simply don't agree on what's right and what's wrong, or what's the right label in this particular case. And so now I'm really going quickly, sorry for that. I want to put forward that, hey, let's pause a moment and look at this disagreement as a sort of signal. So there is nice additional evidence, I really like the work by Swapna, that put forward this kind of data maps. Not sure if you've seen it. I hope you saw it. If not, it's a very nice idea that you just look at, hey, how does my data change over training? And you then plot the confidence of the model and the standard deviation. So what's the average confidence over an instance during the epochs, and how much did this confidence change essentially? And then you plot to what how often it was correctly predicted, right? And what they saw is there are the easy cases and the hard cases, but there are these cases where there's a lot of variability. The model is not sure, right? And they showed that training on these ambiguous cases is actually helping them to do much better on out of distribution performance. So we can really gain a lot from additional evidence that looking at these kind of disagreements. Now this is the model itself; it's not humans in this case, but gives us an edge in generalizability. We try to use this kind of data map then for active learning, and saw that we can also try to get these instances as a better acquisition function. But now I'm skipping over this as well. The question is, what can we do with this disagreement? And there is a lot of literature emerging in this area that tries to not neglect it. So what can you do? Well, there is some work that says, okay, let me just put it up. Essentially, early work tries to aggregate it, right? And some of these aggregation methods also have a notion of modeling the human annotator. But then they do go to still use a single label in the end. There's others who say, no, we don't want this. We need to actually filter our data because this is noise, this is error. Let's remove it. There's another extreme. And so the other, instead of resolving this disagreement, the other direction is, hey, let's embrace it in learning. And now you can again look at the literature and see, we can try to learn models directly. Imagine you ask 10 annotators, you get 10 labels, and try to learn from that directly. Or go to some middle ground of learning with one label, ground truth, and enriching it with this information from the multiple annotators. And I think there's a lot to be done in this direction. And we are touching on this, scratching the surface. And we proposed a simple way to use essentially the typical setup with a gold label, and then learning also the annotator distribution. So, hey, what if we learn still the single gold, but use this disagreement as a sort of regularizer, right? And we saw that this is actually helping us to build a better model. So we tried this on several tasks, and I can point you here to this survey where this is joint work with many people, including Massimo and Delcoe, and we try to exploit this information essentially. Yeah, sorry, this is very fast. Last remark, but they're all really, we assumed still in evaluation, for instance, there's a gold ground truth, which is not realistic. So this is a problem that really touches upon the data process, the modeling process, but also the evaluation process. And we need to go much deeper into this. So is human label variation really something so bad? I think no, actually there's a lot of opportunities, because this actually touches also upon the panel kind of topics, right? We want to have more trustworthy and I would say human-facing AI in the future. Why do we still actually model one ground truth, the voice of a single person, right? Why don't we embrace the variety that we see also in the labels? And so I think we need to, there are some ways forward in order to get there is, well, we need more data. lots of data sets don't release the intermediate stages. If we had access to these intermediate stages, or even just multiple annotations, we have a much richer set of information for modeling, for evaluation. So hopefully in future, when you release a data set, you consider that maybe that's valuable to release. It connects also to the uncertainty of the model. If we have multiple annotations, we can also compare them to the model distribution, right? And finally, I think this opens up a whole range of possibilities, because necessarily we cannot assume that, there is this range of variation in labels, but there is also noise, right? There are spammers, there is simply mistakes in the data. So we need to also, study where are these boundaries between what's still signal, what's not signal. And that's why I like to call this human label variation, which opens up a lot of possibilities for the future. And my hypothesis is actually also maybe if getting fewer instances, but richer instances, we can actually do better learning in future, so that we can, get less data and do more informative learning. And I call this fortuitous data. If you haven't heard me talk, this is kind of the term that it's kind of a signal there, which we often don't use. And I've tried in this talk to show you a little bit of these types of fortuitous data. One is this human label variation. The other is kind of this metadata that we can try to think of using. And with this, I think I will actually end up here. Hopefully you got my message that it might be informative to use of this human label variation. I've tried to give you a snapshot of 3 concrete papers that we addressed in the, what we put forward. And with this, I come back to my first slide. I think there is still a lot to be done to tackle variation in input and variation in output. And with this, I thank you for your attention. And for still staying here. Any questions still? Otherwise, I hand over to the closing session.
Thank you for the excellent talk. I still wanted to squeeze in one question about an idea we have. We want to create a document DQA challenge. And one of the problems that we already foresaw is that one question could have many possible answers, and not all the surface forms are the same. So then we would have annotators, we would ask the annotators to annotate every possible surface form, but then again, at inference, we would have the evaluation problem of trying to match those surface forms.
Right.
Do you know of any research or meetings connected to the last part of dealing with that problem?
Good point. So no, but you could use some sort of soft evaluation metrics instead of just hard evaluation metrics and saying, okay, there's just one ground truth. If you have a distribution of possible sensible answers, you could go a little bit in that direction, right? This is some way. So soft evaluation could be a thing to look up it's also connected to the literature on evaluation of generation, although it's not generation, right? So yeah. Hope that helps. Very nice idea. Is this running this year then? Hopefully. Okay. Any more questions? Yeah, one more.
Hi, so I'm going to ask, so we're in this challenge together. So there is another challenge that we've been thinking about is when you mentioned continual learning setting on multitask. So we were thinking about some kind of doing this multitask setting with languages, like training on multiple different scripts on as different domains and kind of incrementally learn them like in an empty multitask learning setting. Do you have some ideas on this kind of how to tackle on this kind of
how to order them essentially.
Yeah, how to
Yeah.
exactly.
Yeah.
That's very interesting. because-
That's a very interesting. There is not so much work on, right? There is only like what's a good transfer language is some work, but not so much on the going beyond just selecting one, right?
Yeah.
The obvious thing would be to look at typological information and try to see if that is reflected in the continual space. You know, if like language, there is even a lot of choice on what kind of resource do you take to say some languages are similar or not, right?
Yeah. Because there are some Latin languages, and then there are some non-Latin languages. Like you have Latin languages like English, Spanish, Portuguese, French, and then you have non-Latin ones like Japanese and Chinese. So it's very interesting how you define the order for this kind of a multitask.
Yeah, exactly. Also, what proximity, or typological tree properties, or contact information about. I don't know if you have some sort of theory that can guide you in, because we did a paper on one paper on continual learning, where we were wondering, okay, people like children learn WH questions before polar questions, right? And we were wondering how this connects to a visual question answering system. And we also saw that now I don't remember exactly, but it was like the system had actually, I don't remember exactly now, but we were driven by this question. Okay, what about humans? Psycholinguistic motivation. How does this reflect in our machines? I think that's very interesting to ground the research question on.
Okay, thank you, and thank you for the talk. It was very insightful.
Thanks a lot. Yeah, thanks, Dan. Any more questions? Most importantly, I hope you took something from the talk, that it wasn't all stuff you knew already. So, all right. Then thanks a lot. And I hope you enjoyed LXMLS. And I'm still around. If you want to talk to me, please just approach me. Yeah. Oh.
Yes, we're now going to the closing session.
Thank you. Sorry, I was not paying too much attention, but I have. It's yours?
Should I remove it? Yes.
No, it's on. Sorry.
Stop sharing. And I should exit this Zoom.
Não fujam, pá. Volta para fugir. Qual é o coisa do projetor?
Não é preciso, é só meter isto.
Não, mas...
Zoom e o transmite para ali faz tudo. Join.
Acho que é.
883, não. 883, 9838, 6662. E agora passo a turn off lecture.
Agora ou é?
Agora, lecture. E turn off áudio and vídeo. Bem da vida. Já, perfeito.
Aí, falta o join o áudio e o vídeo.
Não, agora é tirar o vídeo, join without video, e join without audio. Portanto, without audio.
Como é que faz? É só fechar isto, não é?
É só fechar isto. Without, yes. Got it. Agora para fechar screen.
Por que faz share daquela coisa?
É, o ecrã todo, por exemplo.
É?
Do desktop ou...
Como é que é?
É ali, exato. Se calhar basta isso. Ok, e agora...
Como é que faz o screen?
Boa pergunta. Full screen, boa. E ali, exato, está ali.
Come on, take it away. Onde é que aqui está direito?
Okay, guys, let's get this closed. So please enter. So now we're going to do the closing session. I'm Ramon, you know me. I'm speaking here on behalf of all the organizers that you know. We do this every year, and I normally don't know very much the slides, so it's going to be a fun ride. So as you have realized, at the last minute, we always try to complete some stats, including your own opinions, and we also gather things from our database about the students each year. This year, there were 477 applications, which is below what normally we have, but these are very special conditions. We have 135 registered attendees, which is also quite low compared to other years, but this was also done on purpose. We normally have around 300. 35% female, which is good. It could have been better, but I think overall we're getting closer to parity. If you see a sliding average, only 10% from industry, and this is something that we might be able to improve. So understandably, because of the situation, most of the people came from close by places. It's both the combination of COVID and then supply chain inflation and gas prices. You know, if you had to fly here, you might have realized the prices were a bit higher, right? So normally this looks much more, it's okay, much more spread around, and this year it was mostly centered in Europe, which is kind of, it makes a total sense if you think about traveling becoming more expensive, right? But overall, as always, we have people from around the globe, and this is always nice, and I think it in general it enriches the experience. Okay, regarding the remarks, we didn't have that much votes compared to other years. I think we could, maybe next year we should bother you more, because this thing is important for us, right? Improving the connection between lectures and the lab guide is usually a normal topic. We'll take this feedback seriously, and we're planning changes for next year. Covering other machine learning topics is also like a very typical feedback. I say that the core of the school, and all the organizers agree on this, is NLP and machine learning, and it's also great to have other topics, but in general, that's very much the core, right? The other two ones, I got also this feedback individually. This is basically an artifact, and doesn't happen normally. Normally we have a Sunday free, right? And then people can rest. The banquet is not as exhausting, and then you can also socialize with friends and enjoy Lisbon without worries, right? And this year, because we had to make it shorter for all of these extraordinary conditions, then we didn't have this day. So in that sense, you were a bit unlucky. Normally we do have a day, and these two things wouldn't be a worry. Of course, if you have realized, if you have asked for any grant or anything, the secretaries of the IT are helping us with this, and Teresa and Sara and Rodriguez, they're basically always there giving us their support. Taking into account that right now they're on vacations, so probably they won't be able to respond to your emails immediately after the school. This will take a little while, right? So be patient. It's not that we're ignoring you, and we're not going to give you the money back, don't worry. Okay, so yeah, people would like more frequent breaks in the lectures. That might be possible, maybe. I mean, if we have to prepare coffee breaks 3 times or 4 times, that might get a bit expensive. I think the topic is something we're going to have a discussion about. So we'll probably be able to do something that is more to the taste of the students. I mean, I consider the topics pretty diverse if you focus yourself to NLP machine learning, right? So, but we're always open to bring people from outside. Actually, Kim Young Cho this year talked about proteins, which might be a first, right? So in general, the positives are always, the ratings are always positive. At least the majority of the opinions are positive about lectures and after the talks. The labs were a bit slightly worse than other years. I think that there's a confluence of factors that has to do not with the labs, maybe with the type of times that we live now and the material, and it is something that we are looking forward to work to improve, right? I think in general it happens that, and I think I said this on the first day on the labs, like it starts easy, you don't get confident because then it starts getting pretty hard, right? And you should also take the labs as some sort of set of pointers for things that then you can continue at home. If you maybe try to do everything, it can be pretty demanding, right? Regarding the food, there's this nice suggestion of providing water bottles. I think that's the first one. Fruit. I mean, pastéis de nata are really good. I mean, I could live from that. I come from the States, so it's yeah, more places for sitting down. That's a good one. Yeah, I think that's definitely something that we might be able to improve. People definitely did not like the food in the cafeteria. That's I don't know. I mean, you're students. Where do you study? Like, I don't think. Come on, it's not there. No, it's a reasonable university cafeteria food. Let's be honest, right? Okay. So more options, better quality. Yeah, the banquet is always a good experience. I think the speech, I mean, depends, right? If it's at the end, I don't know if we're in a position to talk too much, or maybe we don't shut up. I don't know. It feels a bit dangerous. We might regret it. People have mobile phones and stuff, so maybe not. Yeah, the place is really wonderful. We keep going there because it's really, really good. And it's a nice experience just on itself, right? Activities like dancing and music. I mean, yeah, I cannot dance, but maybe you can. So you can enjoy it. Not my thing. Yeah, lectures. I guess this is part of the. We've been 2 years online, and this is the first year we do back physically, and there has been a lot of things under the hood that you don't see, a lot of running around and worried about the facilities. And the first day we thought we were not going to make it, and at the end it kind of worked, right? So we acknowledged seats were too small, and there was no support for laptops, but at least we had rooms. And our biggest worry was, my God, it's going to be very hot, so they need air conditioning. And then we get this feedback that the rooms were too cold, which made me laugh a lot. Like, it's really funny. So it's completely the opposite of our fears now. And the quality of the rooms were uneven. We're aware. We're perfectly aware. There's a very cool room, and then the other ones were not as good. But yeah, we're defreezing now. This is our first year post-COVID. So overall, I think more or less the usual rating, maybe a bit more centered around 4 than 5. Yeah, more breaks. Transformers, definitely something that we keep in mind. Maybe graph or neural, that's more complicated, but definitely transformers is something important. And hands-on examples. I mean, we tend to focus on the fundamentals. We want you to understand the fundamentals of things, right? I think that there's great work outside on more kind of implement very quickly a BERT baseline, like Hein Face does it amazingly. I think we try to occupy another space that's about understanding the pieces, right? Learning to hack things in the abstract and finding, but yeah, we definitely can work on that. In any case, we take this seriously, and as every year, we would think how to make this better for next. Of course, this wouldn't be possible without all these exposures that pay a lot of money that goes to your grants and to the grants of the monitors. And we would like to thank them for that. There's also a lot of partners, and those partners are basically paying us, the organizers, are letting us come here, right? And when you think about it, that's a lot of money. We're all very old now and very senior, and we have a lot of stuff to do. So the fact that these companies let us come here is also like a great sign on their part. We wouldn't be nothing without our wonderful and amazing speakers, panelists, all people that work here, that come here from abroad to basically lecture or give evening talks. The monitor team, a round of applause for them. They're really working hard for you to have fun. And then we're going to do the new thing, because we haven't for a long time here. We have basically organized the set of evening talks in the last 10 years. This is only the evening talks, not the morning talks, so we will miss some important people, but yes, as a reference, right? So this started in 2011, right? At the time, we had this thing of putting a title of that year, like learning for the web. And you can see that there's a lot of network, social kind of stuff. Nobody knew anything that basically deep learning was lurking there. We had, as always, amazing speakers, there's understanding, social media, things like this. 2012, still like there's no deep around, semi-supervised, social context, social processing, understanding. 2013, we're still focusing on learning with big data, right? Morphology, translation. Kevin and I did actually a nice talk about deciphering this kind of ancient problem of cryptography using HMMs, these kind of things, right? HMMs were clearly useful at the time. Then 2014 comes, this is a shame, but Ariana is our first female speaker. I think that we got much better at, but this is 2014. Still, like a funny story, like Phil is that compositional semantics, deep learning and machine translation. Phil was presenting the first neural machine translation system that at the time used, this is prior to John's work, right? This is, this used a feed-forward network, and he presented it here. So deep learning we're starting to just show, but we were thinking, come on, feed-forward network to translate, doesn't make any sense. This year, actually, the morning speaker is Joshua Benjo, but he did the lecture on neural networks, so you don't see him here. And we also have Fernando, which is a well-known figure in research, right? So the two giants, they met on the school and they actually had exchange at the end of Fernando's talk. Unfortunately, we don't have that recorded. It's a real pity. But you can see, like, deep learning is not very clearly in the names at this point, right? Things advance, we have still translation, memory networks. But around this time, things started getting a bit neural network based, right? We still have understanding, but then we have deep learning for speech recognition. We have dynamic neural networks, so DyNet. I don't know if you knew that, but it existed prior to PyTorch. And so with neural machine translation. And then start going full blast on deep learning, right? So we have 2018, control text generation, meta learning, 2018, end-to-end speech recognition, speech generation, Joab, basically giving us a talk about what neural models learn. 20, it starts going from just the models to applications, right? Explainability and these kind of things start to pop up, right? Evaluation, explainability, NLP for the real world. At this point, I think Slav has been some years consistently giving a talk that's more like the state of NLP, which you have seen this year, right? And here Slav is already kind of making a talk about the maturity of NLP, right? And next year, Slav again, scale is all we need, so very timely, just thinking about if scale is all that we have, more work about, you know, like what's inside of the models, adapters and stuff like this. And then, well, we will see. This year, you see that we had a lot of interesting panelists, I think a lot of prompting. I hope that that thing goes away fast, in my personal opinion, but maybe we have prompting forever, who knows? I've seen this tweet about prompting is the new work for the future. Like, okay, prompt engineering. So thank you for being here. I hope you enjoy it. And yeah,